Let's discuss a question from engineering mechanics. So what is given is basically we have a uniform cube which is placed on a rough surface, and a horizontal force F is applied normal to one of the faces. So let's say a horizontal force F is applied like this, and at a point directly above the center of face at a height. So this is a bit above from the center of face, so this is 3a by 4, and center will be somewhere here. The height of the CG, it's a uniform plot, so the height will be a by 2. Okay, and now what is asked is the minimum value for which the cube begins to tip about an edge is equal to. Okay, so when you apply F, actually for some values of F higher than a certain value, it will start tipping over this point. So we will consider that case. So at that point when it starts tipping over, this block will be more or less it will be more or less an incline, something like this. I am just exaggerating that inclination, but just when it begins to tip over, you will the entire bottom portion will not be in contact, only a point contact will be there. And at that point, if I consider the free body, you will have N, you will have some amount of friction, okay, small f, and then more or less, I mean, this is just though I have drawn an inclination very high, but this is just when the bottom loses a contact. So it's more or less like this, the left picture which I have drawn. So the height will not much change. It is just 3a by 4 and mg. So you can just consider this block as just a regular block. Only thing is I have just drawn it this inclination as theta, but theta you can just consider it just greater than 0. So at that point of time you will have everything just like the left figure, but just for explanation I have drawn that it's a point contact. So now at about this point contact, the moment has to be 0 for the minimum value, because if I find out a value of f for the moment being 0, and if I get a value of f, now if I apply anything greater than that, obviously the block will tip over. So I have to just find out the minimum value. So for minimum value, I just draw a free body diagram at this point of just when it is about to tip over. I just draw a free body diagram, which is basically the right side figure, and then I just balance the moment. So when I balance the moment about O, the normal force and the friction don't come because they pass through that point. The F will produce a clockwise moment, so F into 3a by 4. So I take clockwise being positive, okay, and mg will be acting like this, and this is basically a by it's a cube, so everything will be a, and this will be a by 2. So that will be producing an anti-clockwise moment about O. So mg a by 2 is equal to 0. Okay, so this is the minimum value, and anything greater than this, so anything that produces a moment greater than 0, anything which produces a clockwise movement positive or a net unbalanced movement, okay, something like this, then it will just tip over. Okay, so I'll just put greater than equal to 0, so that you will get you will get a value which will be the minimum, and anything greater than that will be, so F will be greater than or equal to mg by 2, okay, into 4 by 3. So this is basically F will be greater than or equal to 2 by 3 mga, right? It's a 2 by 3 mga, but a will get cancelled, a's and a's, so 2 by 3 mg. So basically the minimum value is 2 by 3 times mg. Okay, so the answer is 2 by 3. Thank you. This is a simple free body diagram question. Thank you.